we're going to solve the questions when we are dealing with paper 6 questions. So these are your alternative practical questions. So you guys are going to have to draw a lot of graphs, do a lot of calculations, plan your experiments. I'll teach you guys how to plan experiments as well. The question is saying a student investigated the rate of reaction between small lumps of calcium carbonate and dilute hydrochloric acid. The experiment was done at 2 different temperatures using the apparatus shown in the diagram. All other conditions were kept the same. So we have this setup. I have the gas syringe. I'm collecting the gas in the gas syringe. I have calcium carbonate, small lumps of calcium carbonate, and I have dilute hydrochloric acid. And I have to perform the experiment at 2 different temperatures. Experiment number 1. Using 50 centimeter cube measuring cylinder, 25 centimeter cube of dilute hydrochloric acid was poured into a boiling tube. So I took a boiling tube, and in that boiling tube, I have added my acid. The temperature of the dilute hydrochloric acid was measured using a thermometer. So first I measured the temperature. This is the initial temperature, the temperature at the start of the reaction. 10 grams of lumps of calcium carbonate were added to the boiling tube, right? That's the acid. So now I have added my calcium carbonate to the acid. The bung replaced. This is the bung over here. The purpose of the bung is to make sure that none of the gas actually escapes into the environment and all of it goes into our gas syringe. The volume of the gas collected in the gas syringe was measured every 50 seconds for 250 seconds. So the total time for the experiment is 250 seconds. And after every 50 seconds, you're noting down the volume of the gas, the reading on the gas syringe. That is experiment number 1. Experiment number 2, let's see what they're doing. Using a 50 centimeter cube measuring cylinder, 25 centimeter cube of dilute hydrochloric acid was poured into boiling tube. So first step is the same. Second step, dilute hydrochloric acid in the boiling tube was warmed using a Bunsen burner. This is where we are doing it a bit different. Over there, I did not have to heat it up. Over here, I'm heating it up. The temperature of the dilute hydrochloric acid was measured using the thermometer, same as before. 10 gram lumps of calcium carbonate were added to the boiling tube. The bung replaced and the stopwatch started, same as before. The volume of the gas collected in the gas syringe was measured every 50 seconds for 250 seconds. So everything we're doing pretty much the same. The difference comes in temperature. In experiment number 1, we were using room temperature. In experiment number 2, I have now heated up the acid before doing the rest of the experiment. Use the diagrams to complete the tables for experiment 1. Let's go ahead and calculate. Let's see. First of all, this is the thermometer in front of you guys, right? You have to read your thermometer. Okay, so if I read the thermometer, what do you guys think is the reading over here? What's the reading on the thermometer?
You did something 22. You did something
23.
23.
Yes.
23
Yes,
Celsius.
it's 23. It's 23, right? This is your, so we always count from below. So this is 21, this is 22, and this is 23, right? This is 23. So we're going to go ahead and write this down. Our temperature for the acid over here is, one second. So we got the value of what? We got the value of 23.
23 Celsius.
23 degrees Celsius. We don't have to write on degrees Celsius because it's mentioned at the top, but fine. Let's say 23 degrees Celsius. Now, next they're saying you have to note down the volume of gas collected in this table. So in diagram 1, what do you think is the volume of the gas collected? Time
Is it
is
0?
Yes, it's 0. Time is 0. So, of course, the volume of gas collected will be 0. Then in the next syringe, what do you think is the reading?
It's 11.
Are you sure? You want to look again?
Did you just repeat your question?
Sorry, Maru, what did you say?
Did you just repeat your question? Was your voice was lagging?
Sorry, I still can't hear you.
Just
Can you
can you
repeat the
repeat your
question?
question?
Sorry, I can't hear you at all, Maru.
Miss, she meant, can you repeat the question?
Oh,
Because
okay, all right.
your voice was lagging, that's why.
Okay. I was asking you guys in this when time is 50, what is the reading over here on this gas syringe, right? You said 11, it's not 11.
Is it 12?
It's 12, right? You have to take a look. You have to think about what this one small line stands for, right? If you take a look over here, easy way, you guys can figure out what this small line stands for, right? Does it stand for 1, 2, 5? What does it stand for? It's simply count the number of lines. 1, 2, 3, 4, 5. I have 5 lines. Now, those 5 lines are equal to 10. So, one line is equal to x, right? This will
Yes.
become cross multiply. 5x is equals to 10 multiplied by 1. X is equals to 10 divided by 5. X is equals to 2. That means one small line over here is equal to 2. So when I'm going to start counting from 10, it's not going to be 11, it's going to be 12. Then it's going to be 40. Then it's going to be 60. Then 80. Then 20. Right? So over here, our answer is going to be, you said 12. 12 is correct. Take a look at the next gas syringe.
It's 20.
You are saying it's going to be, yes, 20 is correct. Then after that, next one.
Is it 20?
Teacher is something between
27?
20.
27?
Yes,
Not sure.
27 is correct. It's
Okay.
between 26 and 28. So between 26 and 28, we can easily say that it's definitely 27. Correct. 27. Next, they're saying, what about the next two?
32?
It's 32.
Correct. Now after
32.
that,
I think it's 36.
It's
yes,
36.
it's 36. Correct. Okay, let's take a look at the next part. Next, they're saying use the diagrams to complete the experiment for experiment number 2. So that was for experiment number 1. This is for experiment number 2. What's the temperature?
44?
Correct.
It is 44.
Yes.
Plus
Correct. Next, they're saying, over here, volume of gas collected. Again, same as before. What about
First one is
25.
0.
yes? First one is 0. Second one,
The first one is 0. The second one is
Second
25.
one
It's
is
25.
yes, it's 25.
25.
I think.
What about the third one?
It's 35.
34. 34.
It's 35. See, it's between 34 and 36. It's in the middle.
Oh,
right?
okay. Yes.
This is 34 and this is 36. So it's in the middle. So it's actually 35. Okay. After that, this one, what should be the value?
40.
This is 40.
Yes. After that,
40 again.
40
and
again. 40
Then
again.
40 again.
yes, correct. Good. Now let's see. Plot the results from experiment number 1 and experiment number 2 on the grid. Draw a curve of best fit for each experiment. Label your curve. right? So you guys will see on this topic, especially rate of reactions, a lot of the questions are dealing with drawing graphs. You will have to draw. They always, pretty much always, try to give one question in paper 6 about graphs, right? It doesn't have to be from rate of reaction, but they do in majority of the papers. They will try to give one question from the topic of graphs. So you have to be really, really good at drawing your graphs. So let's start with experiment number 1. Our temperature is 23 and our reading is 12, 20, 27, 32, 36. So we're just going to note this. I'll just take a note of this table. This is the graph sheet they have provided us. So we have to draw in the graph sheet that they have given us. Let's draw our graph. Let's see what we're going to draw, right? So when I go ahead and talk about it, on the x-axis, I have the volume of the gas. Sorry, on the y-axis, I have the volume of the gas. And the x-axis has the time on it. Our first reading is at time 0 seconds, right? The first reading was 0 and the time was 0. So our first dot is going to be over here, 0, 0. Now, dot number 2, where is my next coordinate going to be? My time is 50 and if you guys remember, if you guys want me to go back, we can go back as well. But our second value was 12. So at 50, 12. I will mark 12. I will go 50 and now we need to figure out 12. So again, over here, you guys can use the trick I taught you, right? Or you guys can either, over here, it's quite easy. This is an easy graph because each small block is 1. So I can just keep counting 11, 12, 13, 14, 15. Or you guys can use a small trick. This trick you can use is this. If you guys are ever given a graph and you're confused about solving that graph, you're confused about where to make your mark, so you can always use a small trick. Marwa, you and I have discussed this one as well. The trick that you guys can go ahead and use is simply this. That first of all, count the number of
first 10 lines.
Yeah, count the number of small lines. So there are 10 small lines, okay, or 10 boxes. Count the number of, we have 10 small boxes. 10 small boxes is equal to 10 centimeter cube, right? So let's say you guys want to make the mark at 12 centimeter cube and you are confused. You're like, okay, I don't understand this graph. I don't understand what scale they have used. How do I solve this? If you guys are ever stuck, just do this. 10 boxes is equal to 10 centimeter cube. So 12 centimeter cube will be equal to how many boxes? And then you solve for x, right? So 12 multiplied by 10 will become 120. 10 multiplied by x will become 10x. 120 upon 10 is going to be equal to x. I get 12. So my next dot is going to be 12 boxes. So you can simply count the boxes 10, 11, 12. So that's just a trick, right? You don't have to use it in simple graphs like this. I won't bother using it, right? But when I'm dealing with like really complicated graphs where I don't understand, you guys are in the exam, you're stuck, don't understand the graph, use this trick to help you figure out where to make your next mark, right? After that, the next temperature reading given to us in our over here in our box that they had given us the exam, the next temperature reading is, 1 second, we had 100 seconds and 100 seconds and the reading was 20. So we're going to go ahead and continue with that. We have 100 seconds and we have to make a reading of 20. So I'll go 100 and at 100, I will make a mark at 20. This is 20 and this is, right? Okay. Continuing on after that, my third mark should be at 150, 27. So I'll go back 150, 27. At 150, I need to make 27. So again, you guys can use the method I have used, or you can just count the boxes, because over here, each box is equal to 1. So I go to 20 and then I just count to 27. So 1, 2, 3, 4, 5, 6, 7. This is over here is going to be 27. Right? After that, so if I continue with the table, right? So we have 200 seconds, which is 32. So at 200 seconds, I go up to 30, and then I count up to 31, 32, and finally I have my 250 seconds at which I should have 36. So 250 seconds at which I should have 36, right? This is my graph number 1. And I'm going to go ahead and draw a line of best fit. A line of best fit is a line that should go through majority of your points. Remember that. A line of best fit will
Teacher,
go.
it kind
Yeah.
of looks like a curve, right?
Yeah, it is a curve. Exactly. It's a curve. You and I studied that the rate of reaction graphs are always a curve. Remember, that's what we had studied. And I had
Yes.
told you, yeah,
Yes,
so
teacher.
it's a curve. Exactly. So our line should be a line that is going through the all of the points, right? Now that
Yes.
is graph number 1. Graph number 2 is again over here. This is experiment number 2. So we have to make it for both the experiments. So again, let me just quickly note down these values. And now let's go back and draw our graph again. Okay, again, if I go ahead and take a look, so my first one is basically going to be, again, it's 0, 0. So I make a mark over here at 0, 0. Right? Next reading is at 50, we have 25. So I go to 50 and I go to 20, 21, 22, 23, 24, 25. I'll make a mark over here at 25. Then I have 100, and at 100 I have 35. So I go at 100 and I go to 30, 31, 32, 33, 34, 35, right? Then I have 150 at which I have 40. So at 150 I have 40. I make a mark at 40. At 200 I also have 40. So at 200 again I will make a mark at 40, and at 250 my reading is also 40. So I will go ahead and make a mark at 40. And then I will make my line of best fit, which is going to look like this. Right? This is how my two graphs are going to look like. So automatically, I think we can go ahead and discuss a few things about these two graphs that we have just drawn. So the graph in red, as you can see, the
It's a
gradient is,
little steeper.
yes, it's
That's
actually less,
steeper.
yeah, it's less steep. The gradient is lesser. It is less steep. While the
Yeah.
graph in blue, the gradient is much, much, much steeper.
It's much
right?
steeper, but at the end it's horizontal.
Yeah.
It's getting flat, so it means like the
Yes.
carbon dioxide it's stopped.
Like the
Yes,
reaction is
exactly.
used up.
Reaction
It's
stopped. Exactly.
or
So
used up.
it stopped. Basically, it stopped. Right. So at 150 seconds, the blue graph is telling us that the reaction stopped. In the red graph, we never reached the stage where the reaction stopped because we did the experiment till 250 seconds and we don't have the readings for afterwards, right? So even till 250 seconds, the red graph was still the reaction was still taking place, right? For the red graph, we still had not reached the stage of completion. Why we had not reached the stage of completion? Because of course, the temperature was low, right? The experiment number 1 was at room temperature. Experiment number 2, we had heated up the acid and then we were doing the experiment. So experiment number 2 was when we had provided high temperature. That increased the rate of reaction. So the reaction finished within 150 seconds. In the red line, not only is the gradient lower, but we never reached the stage where the reaction finished. That's how slow the reaction is, that within the 250 seconds, the reaction did not even finish. Now, from your graph, deduce the volume of gas collected in experiment 2 after 120 seconds. Show clearly on the grid how you worked out your answer. What do you do in situations like this? They're saying experiment number 2, that's the blue graph, after 120 seconds. So first thing is first, let's zoom in the graph a little bit. Okay. You're going to go on the x-axis and you're going to read 120 seconds. You can either figure out how many lines it is, how many lines is 120 seconds by using my method, right? Or you guys can just count. Okay, on the x-axis, if I take a look, you guys will see that my one small, this is not when I talk about the scale, right? This is from 0 to 50, right? So how much is one small block? How much is one small block? That's what I have to figure out. So either you guys can figure out using my method, or you guys, once you guys are good enough at it, you can figure out simply by looking at it, right? Over here, one small block is equal to 5. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. So one small block over here is equal to 5. Or you guys could simply figure it out by using my method, the method I taught you guys. You guys could have said over here, when you talk about it, you guys could have gone ahead and said that, okay, uh, 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 10 boxes, 10 boxes is equal to 50. 10 boxes.
Miss?
Yeah, I know Marva got disconnected.
Yes.
Is equal to 50. So we want to know 120. So how many boxes is equals to 120, right? So you can calculate it this way. You can either do, you can either find out what is the value of just one.
Do we divide or multiply?
You will
Yeah.
cross multiply. First, you will cross multiply like so. Hold on, let me write this down in one line so it's easy to understand. Okay, write it down like this. 10 boxes is equals to 50. So how many boxes will be equal to 120, and then you multiply it like this. So 120 multiplied by 10 becomes 1200, and x multiplied by 50 becomes 50x, and then you will divide. 1200 divided by 50 is equals to x, right? So when you're going to go ahead and talk about it, what are you going to see? You are going to end up getting your answer as 1200 divided by 50. You get 24, right? So that
Yeah.
means I will count 24 blocks. So 10 over here, 20 over here, and then I will count 4 after 20. 1, 2, 3, 4. This is 24, right? Now, after you have calculated, how are you going to find the value? Now, it's not important just about finding the value. You also have to show in the graph how you're getting your value, right? You're going to have to show as well how you're actually getting your value. So how are we going to show how I'm getting my answer? We have to draw certain lines. First thing is first, you're going to draw a line that is coming at 120. So you're going to draw a line that's coming at 120. You keep drawing it straight up. In the exam, make sure you use a ruler for this until you get to the blue graph. When you reach the blue graph, now make a horizontal line until you touch the y-axis. And now find the value. So y-axis is quite easy to read because each box is only 1. So this is 30, 31, 32, 33, 34, 35, 36, 37. So when I'm going to write down my answer over here, What am I going to write down? I'm going to go ahead and write it down as 37.
37.
Next question that they are saying is,
Explain how the result shows that the reaction in experiments 2 has stopped.
if I take a look at this graph, this blue line is for experiment 2. How can you tell that the experiment has stopped?
By
Like
by
when the graph gets flat, like the horizontal
Yes.
after
Well,
Yes.
this
150.
because the graph because the graph has reached a plateau, right? So you can say you
yes.
can use the term plateau. The graph has reached a plateau. Next, they're saying predict the volume of gas that can be collected in experiment 1 after 800 seconds. Explain your answer. You have to predict. Just give a general prediction. How much gas do you think will be collected in experiment number 1 after 800 seconds? The red line is experiment number 1.
Yes. It's gonna be continuous, right? It's gonna be continuous like after 800, so it's gonna be
It's okay, take your time. Both of you take your time. Think about it. This is something you need to think about it a bit. Again, they're saying predict. Predict means you don't have to worry about calculations and stuff like that, right? Predict the volume of gas that would be collected in experiment number 1 after 800 seconds. So after 250 seconds, I have around 35. What is the maximum volume of gas that can be produced?
50.
40, right? In experiment number 2, we reached 40 and then the reaction stopped, right? And in the reaction, both the reactions, the amount of calcium carbonate and the amount of acid is the same. I am not changing the mass. I am not changing the concentration. I am using the same amount of reactant, which means that the final volume of gas should be the same. So in experiment number 2, the final volume of the gas was around 40, right? The
Yes,
final
yes.
volume of the gas was 40. That means 40 is the maximum amount of gas that can be produced with this much acid and this much solid.
So it
If
cannot
I
go
change
over.
this, if I change this from 25 to 30, then I will get more gas. For me to get more product, I need to change the reactant. But since the reactant in both experiments is the same, final volume is going to be the same, right? So both of them, the final volume is going to be 40 in both situations. So after 250 seconds, right, the volume of gas produced by experiment number 1 was 35. You guys can take your time, think about it. You just have to, like I said, predict.
Okay, so the maximum volume of the gas is 40.
Yeah,
So it cannot be exceeding the 40. It cannot be like higher than 40.
yeah. It can't be higher than 40. 40 is the maximum, right?
Yes.
40
So
is the
it could be
maximum. It's not going
it
to be high.
it could be, I think, doubled. Since it's 800, it's gonna be doubled. So
So yeah, they are saying you and I know it can't be greater than 40. 40 is the
yes.
maximum that we are getting. We cannot go past 40. So the question is that at 250, it is around 35 centimeter we have collected. So at 800 seconds is like quite ahead. So at 800 seconds, what is going to be what do you guys think, or what do you guys predict is going to be the volume of the gas collected? How much gas would we have collected? And of course, you have to give an explanation as well. What is the reasoning? Why are you saying this particular number? Remember, it cannot be greater than 40. It cannot be
It
greater
cannot.
than 40.
Okay.
It cannot be greater than
So
40, right? Because the volume of the
yes.
gas depends upon how much acid I'm using, how much
Yes.
reactant I'm using. That's the same. If the reactant is the
Teacher,
same, yeah.
is it like 37?
Okay, why are you saying 37?
Because but that was at the calculation. Did you solve it for the part? No, a different thing. Never mind. Sorry, I was confused with it.
Okay, look. When you're going to go ahead and talk about it, what is the maximum we can reach? We can reach 40, right? So at
Yes, teacher.
800 seconds, probably looking at the shape of the graph, by the time we reach 800 seconds, we would have reached the end of reaction, right? I mean, we're pretty close. At 250
So it's
seconds,
gonna stay 40, right?
yeah, at 250 seconds, I am already at 35. So by the
Yes.
time I will reach 800 seconds, I would most definitely have reached the maximum volume that can be collected, and that is 40.
So it's gonna
By
stay.
800 seconds,
It's
yes,
gonna stay the same.
yes. So that's exactly what you're going to see over here. You're going to see the maximum volume of the gas that's probably collected is around 40 centimeter cube. And what is the reason for that? For that, you're simply going to go ahead and say that the maximum volume of gas collected in both experiments will be the same, because maximum amount will not change. The maximum amount will only change if I am changing the reactants. As long as I keep my reactants constant, my maximum volume will not change. Remember that. A student stated it would be an improvement to measure the volume of gas collected every 25 seconds. Explain why this is an improvement. In this question, they were noting down the volume of the gas every 50 seconds. Another person has suggested why every 50 seconds? Why not every 25 seconds? He is saying that would improve our experiment. How will this improve our experiment?
I feel like
It's gonna
it's based on the time, since in the experiment it's measuring every 50 seconds. Is kind of a long time,
Uh-huh.
while the person suggested 25 seconds. It's a
Yes.
bit faster. It's a bit faster than 50 seconds.
Right.
So
Okay. So, but then, how does this improve our experiment? Because my experiment will happen in the same way. I am still doing it for 250 seconds. Total time is the same. I am still getting 40 centimeter cube of gas. Temperature is the same. Everything is the
so
same.
everything is
The
the
only
same.
difference
It's
is,
just the seconds is different.
Yeah, it's just that instead of noting down the gas, how much gas I
Yes.
have, instead of noting down the reading, every
Yes.
50 seconds, I'm doing it every 25 seconds. Now,
Yes.
why is this an improvement? The reason this is an improvement is because when I will make my graph, I will get a better graph. How?
Or
Right now, I will,
better curve or something.
Teacher, we
yeah,
will have more values to draw on the graph.
yes, we will have more. Yes, exactly. We'll have more values available. I will have a value for every 25 seconds, right? Instead of every 50, I will have a value at every 25 seconds. So when I will draw I can make a better graph and I will be able to see the trend or the shape of the graph much better. That's why, right? So it's going to be an improvement because I will have more data, right? You said more points. The better term is more data. More data means that I can make a better graph because now I have more information and that will allow me to better see the trend or better understand the relationship pattern, whatever I'm studying, I will be able to see it better. Okay. After that, they're saying state two changes to the apparatus to improve the accuracy of the results obtained if the experiment is repeated using the same thermometer. So they're saying same experiment, but we need to make two changes to this setup so that our results are more accurate. What two changes can I do to this setup so my results are more accurate?
We could replace the bigger pieces of calcium carbonate with smaller
No, no,
pieces.
no.
Teacher,
They,
like,
they're,
can
they're,
we
they're not.
repeat, teacher,
Yeah.
can we just do the same experiment 2 to 3 times with different timings?
Okay. Let me
Or
give you.
different like what I mean is like we can use powdered calcium carbonate or
Mhm.
like different thing like powdered we can use we can repeat
I
that.
so okay. First, let me answer you that. Okay, so they are not asking you how you can increase the rate of reaction. They're saying
Yeah,
we
no, no,
don't.
no. I
We
did not
want,
mean.
yeah,
Yeah,
yeah.
I
They're
meant
saying we're doing the same reaction, but we
yes.
want to improve it. If you use powdered calcium carbonate, that will change the rate of reaction. That will increase the rate of reaction. They're not asking you to
Oh.
make it faster. They're not saying make the reaction faster. They're saying we want everything to be the same. Just make it so that our results are more accurate. Our results are more correct. That's what they're saying. So we can't change the rate of reaction. So if you powder it, you will change the rate of reaction. It will become faster. That will change your experiment altogether. You're doing experiment on temperature, not on the surface area. So that is out. Okay. Now for what you said, Marwa, if okay, for your answer, I will talk about two parts. Part number one, you said we can repeat the experiment. That is correct, but not that is correct in one way. The way it is correct is like this, that when you do repeat an experiment, so what we can do is that we repeat an experiment and then what we do is we take out average, like you take out average in mathematics. So I will repeat the experiment and I can take out average. Generally speaking, that will make my results more accurate. Generally speaking, that is a very good way of making your experiment accurate. Repeat the experiment a few times, do the experiment 3 times, 4 times, and then you just take out the average, right? That's a very good way of doing it. But when we talk about second part, I think you said something about at different temperature. So at not at different temperature, same temperature. Okay, we will repeat the experiment as it is. When we are taking out average, we repeat the experiment as it is. We don't do it at different temperatures or anything like that. We repeat the experiment as it is, and then we take out the average. So that is one way, but that's not the answer.
Miss, we can also compare the results after repeating it. After repeating it like 3 4 times, we can compare the results and see if
Uh,
they're the same or different.
okay, okay. So, okay, Marva, I was just letting you know if your idea is correct, but you can't use it over here. The reason you can't use it over here is not just saying, tell us how you can improve the experiment. They're saying, what change will you do to the apparatus? So your answer has to be specific to the apparatus, to the setup you're using. Your answer has to use the setup, not going to use. So average is a very good answer. If they had said, if they had not been specific, if they had not mentioned, use the apparatus, if they had just asked you, how can you make your experiment better? So you can always say, take multiple readings and take out the average. That's perfectly correct. But not here. Because they said, talk about the apparatus. How will you change the apparatus? You can change this apparatus
Yeah,
in two ways.
I'm confused about it.
Yeah,
Confused.
you can change it. It's fine. You can change it in two ways. One way, use an insulating material. Why do I use an insulating material? I'm boiling the tube, aren't I? I'm putting it hydrochloric acid and warming it. I'm heating it up. So what will happen? That my heat energy will go into the surroundings. If I want my results to be more accurate, I can put an insulating material around it. That will trap the heat inside the bottle, inside the tube. So my result will be more accurate. Because right now, my heat is being lost to the surroundings. So my result is not as accurate as I think it is. So if I add an insulating material, that will trap in the heat inside my tube, and that will make sure that I'm getting a more accurate result. Not only that, second thing we can do is, this is more related to your apparatus. They are saying we are measuring the acid using a measuring cylinder. There is another apparatus that we have that would be better. Instead of using a measuring cylinder, you can use an apparatus that we call a pipette. A pipette looks like this. It has a bulb at the top, and then we have the tube with the marking on it. So what we do is that we press the bulb and the liquid comes in. The liquid comes into the tube. This pipette is used whenever we want 25 centimeter cube of anything. Because this pipette collects 25 centimeter cube of liquid. So whenever I want to calculate, whenever I want exactly 25 centimeter cube, whenever I want to collect exactly 25 centimeter cube of any liquid, pipette is the best choice. I can use a measuring cylinder, I can use a beaker, I can use any other chemical apparatus, but this is known as a pipette. A pipette would be a best choice over here because it collects exactly 25 centimeter cube. So instead of using the measuring cylinder for it, I can use a pipette. So those are the two changes you can make to the apparatus. So over here, we talked about the apparatus. We didn't talk about average. We didn't talk about the reactant. We didn't talk about any of those things. We're talking about the apparatus, the instruments we're using in the experiment. So your answers were all fine. They would have been fine if they did not specifically say apparatus. Since they use the term apparatus, so now we have to keep our answer particular and specific to the apparatus. Making sense?
Miss, can you repeat that part again? Because I'm still
Yeah.
confused about that.
Yeah, okay. So first change that you can do is that you can add an insulating layer around.
So it can protect the tube since it's a
Yes.
glass.
Yes, so what that will do is that will trap in the heat inside the tube. So when the heat will be trapped inside the tube, my result will be more accurate, right? My result is going to be more accurate because I'm not losing any of that heat energy to the surroundings. Right now, I'm losing that heat energy to the surroundings. So my experiment is not actually going the way I think because I want to know what is the role of temperature. How is temperature affecting the experiment? That's what I want to know. But my temperature, my heat energy is going to the surroundings. It's not going to my experiment. So that will make my results inaccurate, right? So I can add an insulating layer that will trap in the heat energy and that will make it so that my experiment is accurate, right? Second thing is that they said in this experiment they collected 25 centimeter cube of acid. So to collect this acid, to measure the acid, they used a measuring cylinder. A measuring cylinder is fine, but we have this instrument in chemistry we call pipette. Okay, pipette is like a glass tube, and on the top of it we have this sort of a bulb. Okay, we press the bulb, and the liquid and the liquid sort of like in a straw, you suction up the thing. So just like that,
Yes.
the liquid sort of suctions into the tube. Okay, so the pipette collects exactly 25 centimeter cube of solution. Exactly on the dot, it will collect 25 centimeter cube. So instead of using a measuring cylinder to add it slowly, wait until I reach 25, and then I take it out, I can just use a pipette. Pipette will collect on the dot exactly for me. It will collect 25 centimeter cube, and then I can use it for my experiment. So that will eliminate chances of human error. For example, you're using a measuring cylinder, so maybe you did a bit of a mistake. Maybe you took a little bit more, a little bit less, right? A pipette will collect exactly 25 centimeter cube. So my result will be more accurate. Making sense now?
Yes.
Okay. Now, this is another type of question that you guys are going to see in your past papers quite a lot. Catalysts are substances that which increase the rate of reaction. Okay, one second. I had another question over here. Let's take a look at this one. This is last question in your paper 6 is always going to be about planning an experiment. So they will give you the information and they will say plan an experiment. What does the question say? Dilute hydrochloric acid reacts with calcium carbonate to make carbon dioxide gas. The apparatus shown in the diagram can be used to follow the progress of the reaction. The carbon dioxide leaves the flask, causing the mass shown on the balance to decrease. So this is the loss of mass technique. I told you guys different techniques we can use to calculate the rate of reaction. This is the loss of mass technique. Plan an investigation using the apparatus shown in the diagram. Find out how the temperature of dilute hydrochloric acid affects the rate of reaction. So what is our objective? What do we have to find out? How the temperature of the dilute hydrochloric acid affects the rate of reaction. That's what we have to find out, right? So how are we going to plan an experiment? Step number 1. First, always write down the aim or the objective. So our objective is that effect of temperature on the rate of reaction. Step number 2, you need to figure out what is your independent variable and what is your dependent variable. What is an independent variable and what is a dependent variable? Okay. Remember this. An independent variable is the variable that you control. What can you control in this experiment? What can you control in this experiment? The temperature. You can control the temperature, right? I can increase the temperature or I can decrease the temperature. How much am I going to increase it? How much am I going to decrease it? That also depends upon me. The variable that I'm going to control, that is the independent variable. The dependent variable is the variable
That you
that,
cannot control.
yeah, that you measure basically. What am I measuring over here? What am I trying to calculate? I'm trying to calculate my rate of reaction. So my independent variable, what am I going to be controlling? What am I going to be changing? I'm going to be changing the temperature. And after changing the temperature, I'm going to calculate my rate of reaction.
Reaction.
And then I'm going to see what is the relationship? How is the temperature affecting the rate of reaction, right? So that's the first thing you do. You write down the aim, and then you figure out your independent variable and dependent variable. So independent variable is the variable that you're going to be controlling, right? So what can I control, or what can I change in this reaction? I want to change the temperature. And the temperature will, so when I will change the temperature, what will happen? Rate of reaction will change. I will calculate the rate of reaction. I cannot control the rate of reaction, but I can calculate it. So rate of reaction is my dependent variable. The third thing you have to decide is your control variable. What are control variables? Think of it this way. If I want to perform my experiment, now I only want to see the effect of temperature. That's it. I don't want to see the effect of anything else. I don't want to see the effect of surface area. I don't want to see the effect of concentration. I don't want to see the effect of anything else. Right? I just want to see the effect of temperature. Now, I am changing the temperature. Fine. But what if I am also changing the mass of the reactant? When I compare the two experiments, can I actually compare them? Is my comparison going to be valid? If I come up to you guys and I say, okay, at 10 degrees centigrade, this was the rate of reaction. At 20 degrees centigrade, this was the rate of reaction. So temperature increases the rate of reaction. For example, I came up to it and you said that. And then you looked at my experiment and you said, but you used different amount of acid. You used different amount of acids in both the experiment. How do I know that the answer you are saying that temperature increases the rate of reaction? How do you know it wasn't the acid? You used more acid. Maybe it was the acid that increased the rate of reaction. How can you say it was the temperature? Right? So my comparison is not valid because because I have not kept any. I have not control my other variables. The only variable that should change is temperature. Temperature should be the only thing that is changing. If temperature is the only thing that's changing and everything else is the same, and then I come up to you and I say that you can look at the results, temperature increases the rate of reaction, you will say, okay, yes, that makes sense. I mean, everything else is the same. Temperature is the only thing that has changed, right? Everything else is the same. So yes, you must be correct. Temperature must be the one that is changing the rate of reaction. So in our experiment, except for temperature, we're going to try to keep every other thing the same. That's what we will try. Every other thing that we should use should be the same. Okay, that is what we're going to go ahead and try. That's what we're going to aim. That's going to be our purpose. You can't actually do this. There are some things that you cannot control, but we will try our level best that any other factor, any other thing that can affect our results, we control it. We keep it the same. So then when I compare the two, we can say, yes, your comparison is valid. Your comparison makes sense because nothing else is there. Everything else is the same. So in this situation, what should our control variables be? I'm using calcium carbonate. So mass of calcium carbonate should be the same. Right? Because if I change the mass of calcium carbonate, that will increase the rate of reaction. Surface area of the calcium carbonate should be the same. Right? In both my experiments, in all the experiments I'm doing, I should make sure that the surface area of my calcium carbonate is the same. So that means that if I'm using, for example, powder, I will use the same powder in both of them. That will make sure that my everything is the same except for temperature. Everything has to be the same except for the temperature, the independent variable. The concentration of the acid. My hydrochloric acid, all the experiments, I should use the same concentration. Otherwise, that will also affect the rate of reaction. I should use the same volume of acid. My volume of acid should also be the same. If my volume of acid is changing, that is also going to affect the rate of my reaction. That is also going to affect the speed of my reaction. So I want to make sure that my volume of acid is also going to be the same. Then time interval. If in experiment number 1 I am measuring the volume or the mass actually after every 20 seconds, so in experiment number 2 I will do the same thing. I have to decide on one value of time and have to stick to it, right? I'm not just going to keep on changing the time. One experiment I'm looking for 10 seconds, the other experiment I'm looking at 50 seconds. Of course, I'm going to get different results, right? I have to make sure that I measure it for the same time interval. I'm using the same value for my time. Other things now, we are measuring temperature. So I want to make sure that when we go ahead and we talk about it, that we use the temperature of the surroundings is the same. In one experiment, I did it in a very cold room. The other experiment, I went in a really hot room. That's going to affect my results, right? I mean, because I'm talking about temperature, that's going to affect my results. My heat is going to the surroundings. I want to make sure that the surroundings have the same temperature. If I'm doing it in one room, I'll keep on doing it in the same room. The same room temperature should be the same for all the experiments, right? So that's the first thing. These are the first 3 things you write down. After writing these things down, then you will start writing down your methodology. That is how you're actually going to perform the experiment. What are you going to do, right? So let's say you are going to do 2 experiments. One is at 30 degrees centigrade and one is at, let's say, 50 degrees centigrade. Okay, 2 experiments. Or one is at 25 degrees centigrade and one is at 40 degrees centigrade. Okay, let's do 2 experiments. Okay, so first thing you're going to do is that you're going to set up your apparatus, right? You're going to set up your apparatus, and after setting up your apparatus, you will add your calcium carbonate to the, you will add your calcium carbonate to the, or forget that. Set up your apparatus, and after setting up your apparatus, measure out, let's take 25 centimeter cube, okay? Measure out 25 centimeter cube of acid using the pipette. I told you guys, whenever I want this value, 25 centimeter cube of any liquid, pipette is the best instrument. So I use a pipette, I take out 25 centimeter cube of the acid. Pour it into the conical flask and then measure the temperature. Right? Note down the value, whatever the temperature is, and then add 10 grams. Let's take 10 grams of calcium carbonate and add the cotton wool. The reason we add the cotton wool is to prevent any splashing out. Cotton wool is not to trap in the gas. The gas is still lost. A rubber bung traps in the gas, not a cotton wool. Okay? A cotton wool is simply to make sure, because the reaction is happening, so when I add the calcium carbonate, the acid can splash out. Or when the reaction is happening, the acid can, spray out, splash out. So we want to make sure that that doesn't happen. So that's why we add a cotton wool at the top. Right? Record the balance reading or the weighing balance. Record the balance reading every 50 seconds for 300 seconds. Fine. Then you record the balance reading. So whatever the balance reading is, you're going to record it. Subtract the initial mass from the final mass to calculate the loss in mass every 50 seconds. So what's going to happen? Let's say at the start of the experiment, I had 260. After 50 seconds, the reading became 240. So what was the loss in mass? How much mass was lost? To calculate that, I will have to subtract them. So I will get 20. So how much mass was lost in 50 seconds? 20. Then after that, another 50 seconds passed. So it went from 240 to 230. What was the loss in mass? 10 grams, right? So I have to make sure that I'm measuring the loss in mass. I don't just want the mass. I want the loss in mass. So I will subtract. I will subtract the initial mass from the final mass every 50 seconds, and that will tell me what is the loss in mass. How much mass is decreasing, right? Then we will do the experiment again. Again, set up your apparatus like so. And then what are we going to go ahead and do? We are then going to go ahead and heat it up using a Bunsen burner, right? Then the rest of the process will again be the same. Measure the temperature, record the balance reading, everything else we're going to do exactly the same, right? After we have done, so this is our method. After you have given the method of your experiment, you need to tell your analysis. Your analysis is now what are you going to do with the readings? We have the loss in mass, right? We have the time, we have all of this information. So use the data to plot a graph. Calculate, or you can to plot a graph. Calculate the rate of reaction by using the formula loss in mass divided by time, or calculate the rate of reaction by finding the gradient of the graph. And that's it. So in all of your plan, your investigation questions, I want you guys to add all of them. Your A, your independent variable, and your dependent variable. What variables will you control? What will be your method for doing the experiment? And then how will you analyze the result? Will you make a table? Will you make a graph? Will you do any formula? What will you do? Got it?
Yes.
Got it.
Okay. Okay, guys, we're going to go ahead and stop it over here for today. And then we'll continue on, inshallah, in the next class. All right?